Sir, good afternoon. Sir, we will wait for another 2-3 minutes and let students join then.
Okay, sir.
So now, sir, your vacation is going on?
Yeah, vacations are going on, but I'm in office.
Okay, yes, you are in office, just background.
Good afternoon, sir. I had a question from the previous session. Can I ask?
Yes, you may.
Sir, I was asking
Yes,
that
yes.
you said that if we download something, then only the ransomware can infect us or the device that we have downloaded the picture or video or whatever, sir. So I was asking if we don't download it and if we just view it or anything like that, does it also have the risk of infecting our device?
Yes, just say suppose you visited one web page today. Imagine. Okay.
Yes,
Listen.
sir.
suppose you are visiting a particular website on daily basis. Imagine like that, okay? Because or maybe you can say maybe a newspaper website is there, right? They are maintaining a web page for news, right?
Yes, sir.
You like that, and every day you are visiting that. So what the hackers will do? They will infect that particular web page, okay? And who means web infect means they will put something that whoever visits that web page, basically you are seeing that web page in the front, okay? Hello.
Yes,
Yes,
sir, I
sir.
can hear you,
Continue,
sir.
somebody.
Yes, yes. So basically you are viewing the web page in front, but in background something will be downloaded without your consent or without your knowledge, and that will be executed automatically. You got it?
Okay, sir. Yes, sir.
So in front end, you are seeing some sort of web page, what you like to see, but in background, some sort of malicious.
But
Sir,
sir,
I think we can start now.
Okay, okay,
62 minutes.
okay, okay.
Sir.
sir, but for mobile devices, we have that permission that install from unknown sources on most Android devices. So,
Yes.
if we visit the web page or whatever, so then if that option is turned off, the downloading can still be in progress and we won't have any idea about it.
See, depends your gadget. See, mobile phone security is purely permission based, right?
Yes, sir.
Right. So if you by default don't give any permission, it doesn't do any harm. But if you are keep on giving the permission, yes, 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 something, that time you may miss it out, and you will be installing something. So in mobile also it happens. Sometimes you are visiting a particular page, and something is suddenly downloaded to your, but that you can notice. If you notice, then you can stop it. But if you didn't notice it, then what will happen? Huh? So that is the point. So got it. So we'll see that in next class. I will tell you about that, how it happens basically. Okay.
Okay, sir. Thank you so
Okay.
much.
Okay. This is not the correct class to tell. So okay, I hope my screen is visible.
Sir, sir. Visible.
Okay. Okay. So good afternoon once again. So the this session is on the ARP spoofing and man in the middle attack. Okay. So some of you might have already heard about man in the middle attack. Okay. So what happens basically in the man in the middle attack? I will just give the simple example. There are two parties are there, party A and party B are okay. They are communicating with each other. Okay. So suddenly in between, so party A and party B, they are having a conversation, and suddenly a third party, what they it comes in, and what it does something in such a way that the party A sends data, but to B, but it goes via party C, is middle person, and the party B won't realize it that it is coming from the some middleman. It seems like it is coming from the party A, means legitimate party. And the same is true for the communication from B to A. So A gets the responses from B, but basically it comes from the some middleman. Okay. So this kind of situation it happens. Okay, it happens in cyber attack. So that we are going to discuss, and it happens in a numerous ways. Okay, so man in the middle attack. And this session we are going to concentrate on ARP spoofing, okay, address resolution protocol. You might have heard of it in a computer network. Okay, so we'll see what is the address resolution protocol, what is the purpose of it, and how the weaknesses in this address resolution protocol can be used to perform man in the middle attack. Okay. So this is the outline of the talk. I will just discuss about MITM attacks, different sort of MITM attacks which are there. Okay. Then I will talk about ARP, address resolution protocol, and table, ARP table, and I will talk about ARP spoofing. Then I will give a small demo of a man in the middle, okay, attack, and how it can be detected. Okay, so it will give you some clarity. So you see the diagram. If you look at this diagram, what happens? As I said, there is a client, and server. So server is hosting some important services and client is accessing those services. Okay. So for a particular server, there may be millions of clients will be there. Okay. So I'm considering only one client. So client is having communication with the server. So usual communication is between the client and server. That is allowed. That is legitimate communication. But what happens suddenly? The attacker pops in between. So client is connected to the access point basically at his home, and he's browsing something onto the server, maybe the Gmail server or Google server, whatever the server. So attacker is also connected to the access point by some means, and he's acting as a man in the middle. So what happens in the normal situation? The client request goes to the server, and server response comes back to the client. But here, once the attacker comes in, what happens? The attacker intercepts all the communication, and the communication between client and server happens through the attacker. And the client and server will not notice this thing. Okay, so attacker will do the fake ARP. He will do some sort of technical things. I will talk about that. What he does basically when it comes to the ARP. So when client is sending the response request to server, it goes to the attacker. From there, it will be forwarded through port forwarding to the server. And once server sends the response, server response comes to the attacker first, and then attacker forwards it back to the client. So client assumes that actually it is coming from the server, and server assume that actually it is coming from the client. But whereas someone in the middle is hiding and he's intercepting all the communications. Okay, this is called man in the middle. Okay. Okay, so what happens here? The attacker secretly intercepts and possibly alters the communication. As the attacker is sitting in between, he's acting as a man in the middle. He can intercept all your communication. He can use drops on your communication. Possibly, he can alter your request and response messages also. So he can have the access to your data. He can store the local copy of data. Meanwhile, he can alter the data which is going through the traffic or through the communication. Okay. So basically this attacker is positioned between the victim and the target, allowing them to eavesdrop or modify the data. So consequences can be anything. Consequences can be anything. If it is a sensitive communication is happening, if you are not using HTTPS communication, or if you are not using the secured communication, attacker can eavesdrop on your data. They can look at your data. Possibly they can modify your data also. Okay. Next one. Next one. Some if your communication is an encrypted communication, what attacker can do? Attacker cannot see your data, but at least what he can do, he can re-encrypt that data. He or she can re-encrypt your data, and it will be stored onto the server. So if it is FTP client and if it is FTP server, attacker can store. A client can send a file to the FTP server. FTP server will believe that the file is coming through the client. It will store it. But in between, attacker what he is doing, basically he's re-encrypting the file and it is storing onto the server. In future, if the client wants that data, when he downloads that file back, he cannot read his data because that file is totally different. It is a re-encrypted file. So that kind of scenarios are possible, consequences are possible. Okay. And this man in the middle attack is a very common type of attack. Basically happens in an insecure network where the network security is very poor, and the communication or connections are unencrypted. Okay, so this happens. So basically here, what attacker does, it spoofs the identity of the client and server. So it tells to the client that attacker is the server, and it tells to the server that attacker is the client. It spoofs the identity. Okay, so in that way, it can be happen using by stealing the credential also. Suppose you are having username password pair. If somebody get to know about that username password pair, they can also log into your account. Means they are spoofing your identity and they are logging. Okay, so somebody on your behalf is logging to your the services or to the server and using the services, something like that. Okay. Now there are different types of man in the middle attack. Okay, so let us go through them one by one. First one is SSL hijacking. Okay, so just imagine. So between user and server there is a connection. Okay, so this is called SSL hijacking. So there is a SSL stripping happens. There is HTTPS communication, but certain version of HTTPS can be downgraded to the HTTP. So if the attacker comes in, what attacker does? Attacker downgrades that. Attacker downgrades that communication. So between user and attacker, the communication is purely insecure. Whereas between server and the attacker, the communication is purely secure. So what attacker is doing? So this secure communication he downgrades and make it insecure, something like that. Whereas server is assuming that everything is all right. So server will never question about the whether the communication is insecure one, because client will assume that the everything is coming from the server. So client just want to use the services. Client won't bother about whether it is secure or insecure, because he or she want to use the functionalities. So this is called as some sort of SSL stripping or SSL hijacking. Okay, this is one. Second one is a browser cookies. We know that cookies, right? So cookies are the small files which are used to maintain the sessions. Okay, so you know that these are the small files. So whenever we browse, Nilin, whenever we browse the internet, okay, any websites any web pages we access, they ask us to install the cookies. Okay, sometimes. So basically, cookies are used for the session management or session tracking. Okay, so and these are stored as a part of browser. These are stored as a part of browser inside your computer. Okay, so those will be there. If somebody get to know about those cookies, somebody access those cookies, they can hijack your session and they can start the same session from another computer also. Okay, so if that here in this case attacker if steals the cookies from the victim, the attacker can directly start the session with the server. Okay, this is called as stealing browser cookies. This is another way of MITM attack. Third one is called as IP spoofing. So assume here is a victim. He's a machine with IP address 1.2.3.4, and here is a web server having IP address 5678 something. So I have taken a very basic IP addresses just to understand. And here is attacker. So what attacker will do? Attacker IP address is 1.3.5.7. So what attacker will do? Attacker will spoof the victim IP address. Attacker will assume the victim IP address, and it will craft the messages and send it to the server. So web server then will respond to the attacker. So it is just like called as spoofing the identity of the victim. So attacker is assuming the identity of the victim, which is IP address, and starting the communication with the web server. So this is called as IP spoofing, which is also kind of man in the middle. The next one is called as Wi-Fi eavesdropping. Okay, so Wi-Fi eavesdropping means nowadays almost everyone is using the Wi-Fi. Okay, so what will happen? So this user is connected to the server using the Wi-Fi. Imagine, okay, he's using the Wi-Fi connection. So attacker also will connect with that same Wi-Fi, and what he will do, he or she can eavesdrop onto that communication. So the data which is going through communicated between user and the server will go through the attacker, and attacker will just eavesdrop. Eavesdrops in the sense, attacker will capture all the packets which are going through the access point, and he will study those packets, and he will get to know about what type of protocols, what type of services the user is browsing. Okay, what type of data it is, all those things he can do. So he can capture all that data using a Wireshark. Okay, and he can do the packet analysis. Based on that, he or she will derive some information. Okay, and that information can be used for the next stage of attack. Okay, so the next one here is a session hijacking. Okay, so it is similar to the, okay, so there will be so instead of cookies, there will be some types of session IDs will also be used. Session IDs. So basically, if you know about the TCP/IP protocol stack, so our OSI layer, there is a session layer, which is the software layer. From the top, it is a third. After application layer, there is a presentation, and there is a session layer. Session layer is responsible for creating the session, maintaining the session, and terminating the session, and it will happen through either cookies or the session ID. If that session ID is, attacker get to know about that session ID, using that session ID, attacker can impersonate himself as a user, and he can start the communication with the server. So server will believe on that session ID, and that server will start sending the responses to the attacker instead of sending to the user. This is called session hijacking. Another one is called DNS spoofing. We know the DNS server. What is the role of DNS server? DNS server is responsible for resolving the URLs to the IP addresses. So normally, we as a human being, we are very good at remembering the URLs, not the IP addresses. But the machine in a internet will be located using the IP address, public IP address. So there will be a DNS server. DNS server can be local or can be a global. So DNS server maintains a record of URLs, maintains a mapping of URLs and the corresponding IP addresses, public IP addresses. So whenever a client browse the internet, so the request first goes to the DNS. DNS will resolve that URL to the IP address. That IP address will be given to the client, and then packet will be crafted, and that packet will go to the particular real website. What if attacker compromises the DNS server? Means what if he replaces, instead of original IP address of real website, he puts his own IP addresses. So what will happen when the client will browse that particular URL? The client will get the IP address planted by the attacker, and the client will be redirected to the fake website. So in the fake website, which looks just like original website, client will assume that or he's browsing the original website. He may enter his username, password pairs, or some credentials, and those credentials can be stolen. So in that way, attacker can act as a man in the middle. Okay, so just by doing the DNS spoofing. Next one is man in the browser. Okay, so a browser is an application layer software which is used to access the services hosted by the server. Sometimes the attacker may compromise your browser, because browser is also software and having some flaws or bugs. So attacker is sitting inside a browser. Okay, that is called as a man in the browser. And as you are accessing everything, when you are uploading the file, or you are accessing services or logging to a particular portal, everything you are doing through the browser, an attacker is sitting in the browser. He or she can have access to your data. Okay, maybe there are stored password for websites. There are passwords pairs are there, credentials are stored. Attacker can have access to that data. Attacker can modify your request on the fly and responses, okay, coming from the server. So that is called as man in the browser. In the last session, we discussed about the ransomware. So there is one more way of doing the ransomware attack. The ransomware is not actually sitting inside your computer. It is a part of your browser. Okay, so that is called ransomware in the browser. So when you are downloading the browser, somebody is infected the browser with the ransomware. So basically, you are not downloading the browser, you are downloading the ransomware. That ransomware is a part of browser, and that ransomware will have access to your data, and it will leak that data. Of course, it may not encrypt, it may leak that data. Okay, so that is called data exfiltration. The next one is the email hijacking. You know very well. So there is a victim. Okay, so what attacker will do? Attacker will send the crafted email, the genuinely looking the phishing email to the victim. And victim, as is not so security conscious, he clicked onto the links. The link looks very genuine. Links look for SBI website or any banking or finance institution website. It looks very genuine, but actually it will take you to the phishing website. And then attacker, and this phishing website looks like original website, and then attacker will collect all the important credentials what the users or victim has entered onto that. Okay, and those credentials the attacker will use onto the original website for its for his or her gain, for monetary gain, or whatever damage she or she want to do, he or she can do using these collected credentials. So these are the different types of MITM attacks, and the last one is called as ARP, cost dash poisoning. So that's why I have put in a different color, because we wanted to focus onto this. So every computer normally have the ARP table, that is called Address Resolution Protocol. Okay, table, ARP table or ARP cache. It stores the entries of URL and the MAC addresses. Every IP address and MAC address, because every computer will have the two addresses. One is IP address and one is the MAC address. MAC address will be used for the communication within a LAN, because these devices are connected through the switch. So switch understands only the MAC address. So based on that, it will forward the packets. Okay, so it will do the switching and forwarding of packets. Whereas IP address is also required if sometimes the computer wants to communicate to wants to browse the internet. That time you need to have the private IP address, okay, or sometimes public IP address. Public IP addresses are given to the server. Client can use the private IP addresses from class A, class B, or class C networks. So what attacker will do? Attacker will poison this ARP table. Attacker will tell to the client that I am the server, and it will tell to the server that I am the client. So attacker will assume the IP address of client and tell to the server. Whereas attacker will assume the server of IP address and tell to the client. So in that way, it will ask it will trick the client and server to change their ARP table. And once the ARP tables are changed or poisoned, then the entire communication will happen through the attacker. So attacker can intercept the data. Attacker can eavesdrop on that data, can intercept the data, can store that data locally, and sometimes he or she can modify that data also. So we are more interested into this. Okay, so ARP cache poisoning. So let us come to the ARP. Okay, what is this? So this is basically address resolution protocol is there, ARP. Okay, so it's a network protocol basically used to map the device IP address to its MAC address. As I said, every device will have the MAC address and IP address. So MAC address is a physical address and IP address is a logical address. Okay, so that you know very well. And this MAC address will be used for communication within the local area network. Okay, so the purpose, every device wants to communicate with another device in the same network, and to to have that communication, we need to know the destination MAC address, because the standard topologies nowadays we are creating the local area network. The ideal way to connect the computers is within a LAN is a star topology, and in the star topology, what is the centralized device we are using as a switch, manageable or unmanageable switch. So as the computer having two addresses, IP and MAC, we need the ARP protocol to map them. So there is address resolution protocol which maps the IP address to the MAC address. There is another protocol called as RARP, reverse address resolution protocol, which maps the MAC address to the IP address. Both are there. Okay, so here we are talking about ARP, address resolution protocol. Question is how it works. So to understand this attack, we need to know about how it works. So ARP request and reply. In this protocol, we are having two request. One thing is request and reply. So just see, let us have a look at this example. We are having device A, device B, device C, and device D. All these devices will have the IP addresses. Okay, all these devices will have the IP address. And the centralized device is a kind of access point. We cannot call it as a router. It is a sort of access point, or it can be a switch. So what will happen, as this is a one local area network, because all the IP addresses belong to the same local area network. So within local area network, the communication should happen through the MAC address. So suppose the device A want to communicate with the device B. So device A want to communicate with device B. So to have that communication, this device A will raise the request. It will raise the request. It will say that I am looking for 123.10.20.2. What is your MAC address? So this request will be broadcasted to all the devices, device C, device D, and device B. Device B will see for 123.10.20.2, and device C say, oh, it's me, it's for me, and it will respond. It will send the MAC address. Now this device A will take that MAC address and it will generate the frame, and that frame will be directly forwarded to the device B. So basically how it works, so when you start your devices, your ARP table is almost empty, and when you want to communicate, this machine device A want to communicate with device B, first ARP table has to be populated. So how it will happen? Through request packet, ARP request. The source device broadcasts an ARP request to the network asking who has the IP address, this IP address. The device who is having this IP address will reply back. The device with that IP address responds with its MAC address, and that MAC address will be stored inside the ARP table of device A. Okay. Now the point is, this address resolution protocol is very important for the local LAN communication. Without this, the LAN communication will not happen. It is so essential. But there are some weaknesses are there in this address resolution protocol, just like there are weaknesses in TCP protocol. Okay, so three-way handshake. Because of that three-way handshake, the DOS denial of service attack is very possible. Okay, so there is some security concern. So ARP is inherently insecure. It's insecure and susceptible to attack like ARP spoofing. So somebody can spoof the IP address of another machine. Okay, or somebody will can manipulate, or somebody, okay, so the attacker can trick this device to manipulate or poison the ARP table. Okay, where the malicious actor sends the fake ARP messages to intercept the traffic. So imagine device B is the actual device, but imagine device D is acting as an attacker. So this will say that I am having this IP address. So actually the IP address is this, but this device will say, device D will say that I am having the IP address 20.2. Kindly save my MAC address. So this device, instead of saving the MAC address of device B, it will save the MAC address of device D. So in future, if device A wants to communicate with device B, that as the MAC address of device D is kept inside the ARP table of device A will send that frame to device D instead of device B. So basically, this device D is assuming the identity of device B and it is fooling the device A. This is how it happens. Okay. So how you can check the ARP table? In this way, you can check the ARP table. Okay, so ARP hyphen en or ARP hyphen a in Windows hyphen a, you can say in Windows ARP hyphen en. So here you can see the address. These are the IP addresses. These are the hardware type Ethernet. Okay, hardware addresses, MAC addresses are there. 48-bit MAC, 48-bit MAC address are there. Okay, and there is a flag C stands for connected something. Okay, and there is interface are there. So in this way, the ARP table looks like this. Okay, now just see the MITM based attack scenario. So there is a client. Okay, this client is having some sensitive file. Imagine this client is having some sensitive file. There is a server, there is a file server, and this client want to send this sensitive file to the server. Imagine it is a sort of production server. So you are working as an IT employee, and end of the day, you wanted to push that file to the server. Okay, so because you cannot keep that file onto the client, so you wanted to push that file to the server. So the client want to send the sensitive file to the server. Okay, so what will happen? There will be attacker will pop in. Okay, in the man in the middle. What he will do? He will capture. He will redirect. He will pretend like as a man in the middle. Means he will do some sort of ARP cache poisoning. Because of that, it will tell to the client that he is a server, and it will tell to the server that he is a client. So it will fool both of the client and server. So client file server will assume this man in the middle is a client, and this client will assume man in the middle as the server. So the entire communication will happen through the client, this man in the middle, this attacker. So attacker will capture the traffic. After that, he can attacker will what will do? He can modify and forward the file to the server. Okay, so what attacker can do? So attacker client sent the simple sensitive file without encryption, but what attacker did? Attacker re-encrypted that file and send it to the server. Server will happily accept that file because server will assume that the file came from the client. Okay. Now, so what will happen in between? Attacker can have also the local copy of that file. Attacker can read that file. Data leakage can happen, and the public disclosure of data can happen. And moreover, before forwarding the file, attacker can re-encrypt that file again and send it to the server. In future, if the client wants the file from the server, when the client will download the file from the server, file will get downloaded, but attacker will not be in a position to use the file because the file is encrypted file. So the original file is re-encrypted by the attacker before storing to the server. So these are the consequences. This can happen. Okay, these things can happen. When the client will download the file in future from the server, uh, client will get the encrypted file instead of getting the original file. Okay, so and the client will not be able to download the file. Okay, so this way it can happen. Okay, so I hope this animation explained you what is the man in the middle attack and what are the possible consequences. So what is the core issue? here is the unauthorized interception. So attacker is intercepting your communication in unauthorized way. He or she can manipulate your communication and modify the data in transit. Okay. So what will happen? Manipulation of network traffic using MITM. It will compromise the data integrity. Attacker can read your data. He can eavesdrop. In that way, the sensitive content can be leaked. Okay. So our focus is on ARP exploitation. So ARP cache poisoning allows transparent. Okay. So what attacker will do? Attacker will exploit the weakness in a ARP. Okay, ARP protocol, and he or she will pretend like a man in the middle. Okay. So why is it happen? Because the ARP lacks the built-in authentication and it is vulnerable. Okay. So there is no authentication. There is a lack of authentication in a ARP protocol. Because of that, this man in the middle is possible. Okay. And the possible challenge is that even IDS intrusion detection system may not detect this ARP spoofing. Even you can do it in your Windows or Linux. Okay, because you have to fine tune your IDS. Alerting alone is insufficient because it won't stop the attack. Okay, and some more manual work is required. Okay. Now, just see, this is some sort of test environment is there. Okay, to make you understand the practical thing, I have created this test environment. Okay, so what I did, I have taken three virtual machines. Okay, one is a client, one is attacker, and one is a server. So there is a client, there is a server, there is attacker having IP addresses, and all of them belong to the same network. Okay, they are in the same local area network. Okay, connected through the switch. Imagine like this. So what I did, I took three switches here, three virtual machines here, and through this I will make you understand. Okay. So you see, I'm having one machine. First virtual machine is the client. Okay, and the IP address of this client machine is this. Okay. So if I will say if config, so IP address of this machine is oh, sorry, 192.168.56.106. Okay, assume like this. So just remember the last octet. 106 is the IP address of this client. There is a server. Okay, so server also having the IP address. So let us say I will just issue the if config command, and you can see server is having the IP address 1.108. So client is having IP address 106. Last octet I'm talking about. Server is having IP address 108. And assume there is another computer. Okay, another computer which is the regular computer of your network, and it is infected with the malware, and that malware is acting as a man in the middle, something like that. So the IP address of this computer is 107. So just see here. So client is having IP address 106, server is having IP address 108, and this attacker is having IP address 107. Now let us look at the ARP table. So if you ping, then if you ping, so okay, so if you ping, I can say server. So let us try to ping the server. So client is able to ping the server, means they are connected. They are connected, and the server is also able to ping the client. Okay, just means they are connected with each other. Okay, so as this client and server are connected with each other, they can have any form of communication. Okay, they can access the services running on each other. Okay, some sort of thing, data communication can happen, data exchange can happen. Okay, so I will pause it. Control C. Okay, now as I'm talking about ARP, so this client and server can have the normal communication with each other, can have the normal communication. Okay, so what normal communication I'm talking about here? Okay, so I'm talking about the normal communication like this. uh, Client want to send this file to the server. Client want to send a file to a server. Okay, client want to send a file to a server. So how a client can send a file to the server? So using FTP. Okay, so I'm just issuing the command FTP 192.168.56 dot my server is 108. I will say like this. Okay, it will ask for some credential. I'm just entering the credential, and now like this. Okay, so something went wrong. I'll do it again. Okay, I will do it again. Okay, now I have logged in. Okay, so now what I will do, what is my goal? I want to, there is a file, ls, there is a file. I want to push this file to the server. Okay, and when you see onto the server, ls, there is no file. That client file.txt is not there. So what I will do, I will just push this file. So what I will do, I will just upload the file, I will put the file name and I will just push it. Okay. So it's saying transfer complete, means file is uploaded. So let us see whether file is received or not. You see there is a client file.txt is there. Now this file is successfully received by the server. Okay. Now suppose I want to download a file, suppose, so this is a college upload. So client uploaded a file to the server. Suppose I want to download a file, so I will issue the command get and I will issue this. Now this file I want to download, server file.txt. Okay. And just see it is saying that file received. I can verify this file is received or not. I will just issue the command ls and just see server file.txt got received. So this way the client and server can have the normal communication. Okay, they can have the normal communication. So this is what the normal scenario is. Client and server are communicating with each other. Okay, is there any question till now? Hello.
Yes,
No,
any
sir.
question?
Is there any question till now?
I don't think any.
Okay, fine. So this is what the normal communication is we have seen. Okay. Now, so as I'm talking about, so what I will do now, I will try to bring the man in the middle. I will try to bring the man in the middle. This middle machine is the normal machine, okay, as network machine, which is infected with the malware. Okay. So before that, what we will do, we'll see the ARP tables. We will see the ARP tables of these machines. ARP-N. For client, I will see the ARP table. So ARP table looks like this. Okay, it is ARP table. The IP address and the MAC address mapping is there. So for machine 107, this is the MAC address. Okay, because this is attacker. Okay, for this is server, this is a MAC address. Okay, likewise onto the server also, I can see the MAC table, and I can see the IP address and the MAC address binding mapping. I can see. Okay, so every IP address having the unique MAC address. You can see like this. This is just a client. Client MAC address is this. Okay, something like that. This is the attacker MAC address is like this. Okay, so because attacker is also a normal machine, means attacker is also able to ping the client in server. So attacker is also able to ping the client in server. That's what I'm saying. So just see if I will ping the client, it is able to ping the client also. And if I will ping the server, it is able to ping the server also. It is a normal machine which is situated inside your network, position inside your network. What if this machine, this one of the machine is compromised by the malware, and that malware is compromising the ARP table of client and server? Okay, so like this. Okay, so now the point is like this. So now question is, so this is the ARP table on client. So you can see for every unique IP address, there is a unique MAC. For every unique IP address, there is a unique MAC address is there. There is no redundancy, okay? There is no duplication. So how we can check that everything is all right? So normally in normal situation, there should not be a duplicacy of MAC address with same MAC address should not be bind with two IP address. Okay, so that is a normal situation. So we'll check it. Okay, we'll check everything is all right. So there is a script. So that is a detector script is there. I will just say that what is script name. ARP spoof detector script is there. I am running this script and just see what it will show. Say it will ask for password. It will show something. Just see. It is showing me the MAC table and it is continuously checking. It is continuously checking. So you can see the entries here. There are three IP addresses in my ARP table, and these three IP addresses are mapped to these 3 MAC addresses, and there is no duplicacy. Means everything is all right. Everything is all right. Nothing is wrong. Okay, so everything is all right here. So I will just exit this. The same thing I will do here. I will check onto the server whether everything is all right or not. I will check onto the server also. And just see here also everything is all right. It is continuously monitoring this table. Okay, everything is all right. So 3 IP addresses and 3 different MAC addresses. So no duplicacy. So everything is fine. Okay, now. So I will just exit this. Now I will bring the attack scenario. I will bring the attack scenario. Okay. So now what we will do, this machine, this attacker machine is trying to perform, trying to poison the ARP table of client and server. ARP table of client and server, it is trying to poison. Okay, it will try to poison. The same way it will try to poison the ARP table of server. Okay, so we'll see that. Okay, so I need to issue some commands for that. Okay, so I'm running a script onto this attacker machine. Okay, so I'm running one script. Spoof ARP table .sh. Okay, so there is a Python script we are having, and we are running this script. What this script will do, this script will try to poison the ARP table of client and ARP table of server. Okay, so I'm just running it. It is asking for password. So then it is asking for interface, which interface we wanted to do. So there is an interface. This interface is there. We need to enter this interface ENP0S17. Okay, so this interface we need to enter ENP0. So interface I am providing. It is asking for client IP address. So it is 192.168.56.106. It is asking for client 192.168.56.108. Like that. Now it started. Okay, just see. Now it started like this. So it is doing the man in the middle attack. It is poisoning the ARP tables of client in server. Now question is how we can verify that. So again issue the command here ARP hyphen yeah. Now you can see the changes here. Just see, earlier we were having the 3 IP address, and each IP address is mapped to the unique MAC address. But here you can see some duplicacy here. Here you can see some duplicacy. What you can see that for 107 and 108, the MAC address is same. MAC address is same. What does it mean? Attacker is telling to the client that attacker is telling to the client that attacker is advertising this MAC address to the client and saying that I am the server. I am the server. When you look at this ARP icon here, here also the same thing. Basically 106 is a client. Client is having this MAC address, but this attacker machine is telling to the server that I am the client. So it is poisoning the cache, ARP cache of both client and server. It is poisoning. Got it? So it is poisoning. So it got poisoned. So duplicacy is there. There is some redundancy is there. This redundancy indicates that ARP cache is poisoned and it is an attempt of man in the middle attack. Now if we run our script ARP spoof detector, you can see the things. Let's see what it is telling that. It is showing 2 entries as a highlighted one. What it is saying that? It is saying that these 2 machines having these 2 IP address, for these 2 machines having IP address 107 and 108 having the same MAC address. Actually, it should not happen. Every machine should have unique IP and unique MAC. But what is happening here? In ARP cache table, you are able to see that 2 machines having IP address 107 and 108 having the same MAC address. So it is a attack attempt. It is a man in the middle attack attempt. Okay, it is a man in. So at the same time, you can see it here. You see here also at the server side. You can see these two entries are highlighted in the color, and you can see it is showing that two machines having two IP addresses 106 and 107, or both of these machines the same MAC address is there, which is a kind of anomaly. Okay, which is a kind of which is not actually not a normal behavior. Means it tells that this our detector tells that it is the m- attack attempt. And what machine is common here? 107, and here also 107. So who is the attacking machine? 107 is the attacking machine. Now, what you can do? You can do some remedial action. You can isolate this machine. Means this machine, the 107 machine, which is a part of our network, it is acting as a man in the middle. It is acting as a man in the middle. It is acting as a man in the middle. Now you can isolate this machine and you can thoroughly investigate this middle machine. Means because this machine is infected with the malware, and this malware is performing man in the middle attack. Means now if you communicate, now question is, as the man in the middle attack is happening, means what? Entire communication between the client and server will happen through the attacker machine. Entire communication between client and server will happen through the attacker machine. Forward communication and backward communication. Okay. Now we will see that part. We will see that part. So what I want, earlier we have seen that from client I am able to upload the file onto the server. Okay. ls. So here I was able to upload the client file onto the server and able to download the server file onto the client. So for time being, I will remove this file, server file, from here. And here also onto the server, we are able to receive the client file from the client file.txt from the client, and we are able to send the server file.txt to the client. Okay, so I will remove the client file txt from here, and we'll repeat the process after man in the middle. Okay, now here I am having only server file.txt. Here I am having only client file.txt. Oh, sorry. Now let us see the content of this file. Let us have a look at the content of this file. Okay. So what is the content of this file? Content of this file is only one line. Hi, this is a client file. And content of server file is, hi, this is server file. This is the content. Only one line content is there. Assume I am onto the client. I am having file client file.txt having this line. And onto the server, I am having one server file.txt having this file. Now what I want to, now man in the middle is happening. Okay, this ARP tables are poison for the client and server also. I wanted to reshare the same file, client file.txt, to the server, upload, and then download another file from the server to the client. Okay, that I want to do. That is my task. But before that, I need to do something. Because this attacker did man in the middle attack, so it simply poisoned the table, ARP tables of client and server. So here, if the data, now the data, the communication between client and server will happen through the attacker machine. So I need to do some sort of setting here. I need to do some sort of port forwarding, because I will get the traffic from the client. That traffic I will forward to the server. Similarly, I will get the traffic from the server and I will forward back to the client. So I need to do something here, some settings I need to do. I'm going to do that. Some forwarding I need to do. Okay. So I need to enable some forwarding. I need to enable some sort of forwarding. Okay. So I will do that. And now IP forwarding is enabled. Means what will happen? The data is coming from the client will come to the attacker machine, and attacker will forward that data to the server, and the data coming from the server will come to the attacker machine, and attacker will forward that data to the client. Okay, this is what happens. That's why I have enabled the forwarding. So we can call it as some sort of port forwarding also. Okay, now what I will do, I will repeat the process. Okay, now I will repeat the process here. Okay, so the, what I will do, first I will try to intercept the communication between client and server. Means client want to send something to the server, that I want to intercept, that this client file that txt I want to intercept, and I want to modify it. So I will run one script here. Okay, sudo. So this is a Python 3 based file, attack ftp up. I will run this file. Okay, so it is asking for client address 192. It can be automated also. Okay, so why I did it manually, because to make you understand, but our entire thing can be automated. Okay, so when the man in the middle attack will happen, it will not happen manually, it will happen fully automated. So everything can be automated. 106, this is client. Likewise 192.168.56.108 is the server. Okay, now just see. It is monitoring the FTP traffic between 106 and 108 and waiting for file transfer. It is watching for something to come up, FTP traffic. Now what I will do, I will start the FTP server here. 192, my FTP server is 168.56.108, which is this machine, the last machine, server machine. Okay, so I will enter the credential, login. And what I will do, I will try to upload the file. So I will issue the command put. I will upload this file. So just see, we have successfully uploaded the file. It message came, right? Okay, so login successful and send the data. And but here what is happening, just see in the attacker, what he did. Attacker intercepted that file. This is the original data. And what this attacker machine did, it manipulated the data. It added some more content to this. And they injected successfully. And that file came here. Now let us see that file is available here or not. Yes. Client file.txt came to the server successfully. And when you see the content of this, you can see the content is modified. Question is, this is the original content in a client file, but something extra is added to the file what the server received. Now how does it happen? This attacker machine intercepted the FTP traffic, modified, tampered the data, added some extra data to that file, and then forwarded that file to the server. Server received that file. Now server is assuming that everything is going well. It is coming from the client. Server will happily accept this file. Okay, server will happily accept this file and store it. But in future, if the client wants the same file again, okay, so I will see here. Okay, so I will open another tab here. ls. So if I wanted to, so suppose now after uploading the file, I have removed this file. Also, client, this file I have removed. And in future, the file which I have uploaded onto the server, that file I want back. So I will try to get that file back from the server. Uh, okay. So what it is saying that, oh, so I need to start the FTP, sorry. So through FTP, I can only say get not connected. It is saying that it is not connected. So I need to connect it again, okay? So just see. So the point is like this. So one way data is intercepted from client to server, data is intercepted. Client to server, the data is intercepted. But from server to client, that data is not intercepted. So I need to run another script to intercept that communication. Okay. So I will run one more script here. Okay, from downloading. So I will run one more script. Sudo FTP download. Okay, it will ask for credential. It will ask for client address. (106) and oh, wait. Okay, I will repeat this. So I will terminate this and I will rerun this again. Okay. Now, what is happening? It is looking for the communication from server to client. Okay, so other way. So, okay, so client want to download a file from the server. So now, what we'll do, we'll try to get this file back. Okay, so I will connect it again. It is not saying, so I will try to connect. Okay, now I will try to get this file. Okay, client file.txt. Sorry, somehow it's not working. Some issue is there. Waiting for file transfer. Okay, or I will say I'll start FTP here. Local service not available, remote server timeout. Some timeout error is there. Okay, it's supposed to happen. It's supposed to work. Oh, lost connection. I need to log in again. Okay, I will rerun again. I will change the IP addresses. We'll do one more time. I hope it should work. Okay, some issue is there, but I have demonstrated the attack one way. When the file goes from the client to the server, okay, it is getting tampered in between. So when you look at this client file.txt, basically the data got tampered here. So sometimes what happen in the normal situation, okay, basically within the local area network, majority of the time we do use the unsecure, unencrypted communication channel, just like a simple FTP telnet. So if there is a possibility of, if there is a man in the middle attack, the attacker, what they can do, they can tamper your data, they can read your data, which is the attack on privacy, confidentiality. They can tamper your data, which is attack on integrity of the data. If you are having the encrypted communication channel between client and server, what the attacker can do, being a man in the middle, they can re-encrypt your data again. One more layer of encryption they can add to that. And in that way, they can make the data unusable to the both the parties, even the client and the server. Okay. So in that way they can do. Okay. So I have demonstrated the one way. The other way also is working. I don't know, some reason is there because these are the virtual machines. Sometimes some settings may get changed up suddenly. Okay. So don't know. So because this virtual adapters are not so reliable. Okay. So I hope you got the idea. Okay. So let us go back to our presentation. So through the test environment, I have demonstrated the client, server, and the attacker. And the standard topology, okay, is within LAN, the devices are connected to a switch, and switch works basically on MAC address. Switch understands only the MAC addresses. That's why we need a address resolution protocol to have the communication within the LAN. Okay, so we have seen, we have connected to the FTP. Sorry, the IP addresses are different here. We have connected to the FTP, and then we have uploaded a client file. Okay, and then we have downloaded the server file also, so like that. So once you upload the client file, you can see onto the server. So before man in the middle attack, the client file goes as it is to the server, but after man in the middle attack, the client file get tampered by the attacker, which is the man in the middle, and it will be forwarded to the server. Okay, this way the data tampering can be done. Okay, and then we have seen the how to visualize the ARP tables of both client server machine. And then we did a spoofing. Okay, using man in the middle onto the attacker machine, we did a spoofing of client and server. And after that, after spoofing, you can see the MAC addresses are same for more than two machines, which is a sort of anomaly which has to be detected. Okay, so basically this is what the payload injection happened. The client is sending the original file to the server, but basically it goes to the attacker. Attacker modifies the forward file and to the server. In future, whenever, and the client will delete its own file because client may not keep those files with them because already uploaded onto the server. So in future, the client wants his or her file, it will try to download from the server. When it downloads from the server, it will not get the original file. It will get the tampered file. Okay. So this is the way the attack happens. Okay. So we have seen the file upload and file download part. These are some of the commands. Okay, what I have shown to you. So what is the solution for? Okay, so when coming to the solution, what can be done? So I have demonstrated a solution also. So I have run some Python script. Okay, so which will tell you, which will monitor the ARP tables or ARP cache tables very closely. If there is a duplicacy of MAC addresses for more than one IP addresses, that is considered as a man in the middle attack attempt, and it will flag the alert. It will flag the alert. As a part of remedial action, what you can do, you can flush the ARP tables. You have to flush the ARP tables. So if you flush the ARP tables, it will disrupt the normal communication also. There may be some sort of service downtime will be there. What more you think you can do, that you can issue the alerts to the administrator, because if for more than one IP addresses in a ARP cache table, if the similar MAC address is there, then that's an attack attempt, man in the middle. You can isolate the machine, you can identify the attacker machine, you can isolate it from the network, and you can do the deeper investigation, forensic investigation of that machine for the abnormal behavior. Why the man in the middle happened like that, whether that machine is infected with any malicious software or malicious program or not, because the attacker may not do the man in the middle attack physically or personal. Okay, so he will launch the automated code, which is a malware, and it will do the man in the middle attack on the attacker's behalf. So what you can do, you can check for the duplicacy of MAC address, and you can issue the alerts you can issue to the administrator onto the, either through SMS or email or voice call. Depends, different types of SMS. There is a redundancy, SMS, email, and voice call, because if the uh, administrator is not looking at his inbox or SMS, at least he will get the voice call, something like that can be done. So we have seen the detection phase also. So before ARP spoofing, how the ARP table looks like, this our script is watching. when the attack is happening, it shows you that there is an attack attempt. Okay, it gives you the alert. Okay, local alert. Okay, prompt it gives you. And you may get the email alerts also. That email alert and message alert part I haven't shown you because I need to do some settings and configuration, but it is doable. It's pretty easy to do that. Okay, so in this way you can get the alert message. It will tell you that this machine has MAC address. It is having original MAC was this, but now the MAC changed to this. So why suddenly a machine MAC got changed? Because the machine should not, machine MAC is considered as a fix. So why suddenly a machine is changing a MAC, which is anomalous behavior, and who is the likely attacker? So this machine is a likely attacker. So this way the message can be. So this email is sent by the server. This email message is sent by the client to the security administrator, and based on this you can identify, okay, this machine is a likely attacker machine, and you can isolate that machine, and you can closely investigate that machine for the anomalous behavior. Okay, so like this. So what are the existing solutions are there for this? So you can regularly flush and monitor the ARP tables, monitor the ARP tables regularly for the duplicacy of MAC addresses, and you can flush them. But if you flush them, then what will happen, that some service downtime will happen. You can use the static ARP entries. Manually configure the ARP table with fixed IP MAC address mappings. Means the mapping within the ARP table has to be hard coded by the security administrator or the network administrator. It is feasible for the small network, but it is not scalable for the large scale network. Okay. So third solution is enable dynamic ARP inspection. So do the ARP inspection, a security feature available inside a Cisco manageable switches. Cisco provide the manageable switches. There is a security feature is there. What it does, it intercepts and validates the ARP packets. So earlier I said that there is no validation, there is no authentication of ARP packets is happening. Now some Cisco switches, manageable switches does the validation of packets, and based on validation only it will allow to do the changes in the ARP cache entries of the computer. Next one, you can use the ARP monitoring tools, ARP Watch or XR. These tools will continuously monitor your ARP table, and if there is a duplicacy, it will flag an alert. Okay. Next solution, you can implement the port security. You can limit the number of MAC addresses to the switch port. So you can do the MAC binding. You can do the MAC to switch port binding. So the machine is having this MAC only connected to this switch port. That machine should not change. If that machine is changing the MAC, that is anomalous behavior. Okay. You can use the network segmentation. Okay, so you can use the VLANs, firewalls in case. Okay, to reduce the consequence or impact of the man-in-the-middle attack. Okay, so you can, in that way, by doing the network segmentation, you can reduce the attack surface of ARP spoofing. So if one segment of your network is infected with the man in the middle, the other segment of your network is safe. Okay, and as I said, uh, yeah, being a man in the middle, attacker can eavesdrop on your data, and that's a confidential attack on confidentiality. So better enforce end-to-end encryption between the two machines which are communicating within the LAN or any two machines. Okay, so attacker may not be in a position to decipher your data, your private data confidentiality is intact. But what they can do, as they can feel that they can say that as the data is not usable to me, I can make it unusable to others also. So they can re-encrypt again, and it will make unusable for the server or the client machine. So it can be done. So these can be your consequences. Okay, and that's it for the man in the middle attack using ARP cache poisoning. Okay, so now I'm open for the question. Is there any question?
Yeah, I have questions, sir. Can you hear me?
Yes.
Okay. My question goes to in a case of situation like in developing countries like Nigeria, how can we mitigate anomaly-based intrusion detections? Can we be able to calibrate to distinguish between the legitimate ARC broadcast and the malicious ported ARC replies in high throughput networks without like increasing the false positive or degraded network performances?
Can you repeat, because your voice is a bit feeble, you know?
Yeah,
Can you repeat?
can you
Can
hear me
you
now?
say slowly so that
Can
I
you hear
can
me
get?
now?
Yes. Yes.
Okay. I said, how can anomaly-based intrusion detection systems be calibrated to distinguish between the legitimate ARF broadcast and malicious Porter's ARC replies in high throughput without increasing false positive or downgraded network performances.
Okay. So your point is that how you can implement anomaly-based intrusion detection system to distinguish between legitimate ARP packets and the uh,
Malicious.
malicious ARP packets, and there is a concern of false positive also, right? And
Yes.
there is a concern of performance overhead also, right? So
Yes,
how
sir.
you can do that? Okay, so that depends on again the how the attackers is doing that. You see, the ARP cache poisoning, the way I told you, that is only one way. Okay, it can be done in a different ways also. So what you have to do, you have to study the different types of ARP cache poisoning, because you see attacker does the, some just see, uh, attacker when plans the attack, what he does, he studies the existing security solution. He studies them, sees their behavior, how they are working, and then he does certain things in the ARP packets or in the attack, in the attack, uh, in such a way that the your anomaly based system will not detect that. It looks like a normal. So what attacker may do that, okay, so it depends, again it depends on your situation. So one is anomaly based detection ideas. You have to distinguish the genuine ARP packets, you have to distinguish between malicious ARP packets. So okay, so what you can do, just see, definitely what happens basically, this ARP packet is a broadcast packet, right? So suppose a machine want to know the IP address of another machine. So it broadcasts that packet. As it broadcasts, it goes to every other machine. Okay, it goes to every other machine. Now, what you can do, the maybe the pattern of broadcast, or when one machine will try to intercept the communication, it may try to do with the multiple machines also. It may try to do with the multiple machines also. Just see, there is a gateway spoofing also happens, MITM at the gateway. You know the role of gateway. The gateway is a device which connects the local area network machines with the internet, right? So in that attack, what happens? The attacker will pretend like a gateway. Attacker machine will pretend like a gateway. So all the traffic, instead of going to the gateway, it is coming to the attacker machine first, and from there it is going to the gateway. It happens like that. So sudden deviation in the traffic flow, sudden deviation. So just see, for every machine you can have some sort of limit. Okay, how much traffic, ARP packets or some how much traffic comes and goes. If there is a sudden change is happening, that knowledge that you can, that based on that you can create the anomaly based signature, and then you can highlight why suddenly lot of traffic coming to this machine, because this machine is acting as a man in the middle. It is intercepting the communication among all other pairs of the computer. So that is a kind of anomaly that you can use, that you can fine tune, and then you can put in your IDS signature. In that way you can reduce the false positive. Burden, I can say there will be some burden will be always there, because security will not come without a burden. There will be always a burden, but that again you have to optimize. So what you can do, for every machine you can have some sort of threshold. What is a normal behavior? How much traffic is coming in, how much traffic is going out, and suddenly one machine is acting as a man in the middle. Definitely there will be some sort of traffic in or traffic out number of packets that can be used as that. Okay, that can be used. And as you are concerned about ARP packets, similar sort of things can be done, but ARP packets are basically a broadcast packet, so I don't know how much can be done there. That needs a deeper investigation.
But sir, can I be able to use like a machine learning with
Sure.
historical test lined, like to have a clustering based on the MAC IP behavior? Is that one possible?
Sorry.
Is that one possible to use machine learning with historical traffic?
Yes, yes,
Best.
yes. There is a possibility. Just see, your network is having a normal behavior. So record your not network normal behavior, machine's behavior, your all whatever it may be. You record it. Then that's a normal behavior. And when in the man in the middle happens, then what can be done further? Okay, what is how it is deviates from that? Then that has to be investigated whether it is a man in the middle or not. It's possible. There is a possibility of using your AI ML algorithm. There is a possibility. But you should have some sort of baseline, some sort of traffic data, historical data of your network traffic you should have. And on top of that, you can do. There is a
Okay, sir.
possibility. Yes.
Thank you, sir.
Any more questions?
I don't think so. They need the PPTs. Means, so today only I will upload the recordings. Otherwise, if they require.
Sir, these PPTs are created by my master degree students. Okay. Basically, these are the projects done by master degree students. Okay.
Okay, sir.
So once their project presentation will be over, then only I can share.
No problem. I think Ganasam sir, I will upload the recordings. Means I will give the
Yeah,
link.
recording will be fine because simply PPT will won't help them. So if
Yes.
my recording is there, then in that way they can they can correlate and
Today only I
yes,
will try to upload the PPT.
yes.
No questions are there. Again, tomorrow I think sir will meet at 10 o'clock. The
Yes,
topic will
yes.
be
Tomorrow,
live by
hopefully,
download.
hopefully. Sorry for the trouble today. Morning, we got some network hiccups here.
No, sir. It's very helpful as many questions are from the student side. So definitely the sessions are informative and useful. So I think so. So again, tomorrow we'll meet at 10 o'clock. Sir.
Sure, sure.
Thank you very much, sir.
Thank you all.